This is 10.5, number 23, and in this we're using Demoivre's theorem, or Demoivre's theorem, or Demoivre's theorem. I've heard it pronounced a couple different ways. I've always thought it'd be more French, so I'm trying to do it that way. But we're going to use that to find this value. Now, I've done this a couple different ways. We're trying to find roots of it, but I'm going to follow what this book does and try to keep it geared that direction. So instead of treating it like we're looking for, if we have z equals this, and then we're trying to find the roots of z or whatever. I mean, z squared equals -1 plus 2i, then what would be z1 and z2, for example. I won't do that. I'm going to focus on following the way they did this. There's a sample video for this, but it looks like this person already solved it. I was asked, I wasn't told to not do it, so I'm getting to this later in the day than the person asked me. Same day, but later in the day. So let's go ahead and take a look at this. So we will start off by saying our z equals -1 plus 2i. So if we want to find our r equals, I did obviously right here, I did a screen capture, a snippet of what the pertinent formula is here. So that's going to be the square root of -1 squared plus 2 squared. And so we're going to have that equal to the square root of 1 plus 4, which is the square root of 5. Now if we look for tangent theta, that's going to be our y over the x. So our y is going to be 2, and the x is -1. So theta would be equal to tangent inverse of -2. So our theta is, let me get out my calculator. I really wish I had that online calculator tool that this person seems to have. So I'm going to make sure it's in radians, though, not degrees, which I'm used to using degrees for a lot of things we did earlier in this chapter. Second tangent of -2, and I get -1.107148718. Now, what I want to point out is if I had graphed -1, +2, it's going to be here. But the arctangent returns things in these two quadrants. And in fact, the one we're dealing with is down here. And so if we're looking at something going up this way, that angle, we would just add pi to it. So if we add pi to that result, we have 2.034443936. And obviously my calculator stores more digits than that. But my point is, we're not going to need all that towards the end because, well, it looks like this person did have a lot of digits there. Okay, does theta round it off? I usually go 4 digits if I'm doing something like that. But okay, so now we're going to say our z is the square root of 5. So it's that r from up here, times cosine of 2.034443936 plus I times sine of 2.034443936. And if we're going to find z to the 1/2, that's going to be the square root of 5 to the 1/2 times cosine of 1/2 times 2.034443936 plus I sine of 1/2 times 2.034443936. And there we go. I think one more parenthesis does it. Now, our z to the 1/2 is going to be, and now I'll just do some calculations together. So I'm going to do the square root of 5 to the 1/2, so it's basically 5 to the 0.25, cosine of half of this angle. This angle, I erased the 2 by mistake. So we're going to have 0.78615137776 plus I sine, no, I'm not doing sine, we're plugging things in. Then we have the square root of 5 to the 1/2, or 5 to the 1/4, times sine of 1/2 of that angle. Again, that angle is something I kept in my calculator, so I can just paste it in. So that's going to give me 1.27201965. And that's what we had here. Now, I think this person was asking me why did they put the A with the I. And that's not, I still would have written it like this. That's kind of the standard form, so we write the real part first. So I'm not sure if there was some programming issue where it wouldn't take the real part first. So anyway, kudos to the student who got this done correctly, and I hope that helps the rest of you. And this gives you another resource. Let me know if you have questions. Thanks. Oops, sorry about that.